This is section 5.1, and we start our study of transcendental functions. These transcend or go beyond algebraic functions. So we pick up exponential and logarithmic functions. So we talk first about compositions. So let's look here. If you're given two functions, f and g, the composite function denoted by f of g right here, or g of f, is defined by, and these are just the symbols that you would see. It could be f with a little bit of circle, f of g of x, or f and then the parentheses method. So either way. What happens is one function is literally put into another. So in this example, I have f of x is 2x squared minus 3, and I have g of x is equal to 4x. Then if I'm asked to find f of g, it means I'm going to take this g, the yellow one, and go over here and put it in for x. So I have 2 times the 4x squared minus 3, and then you clean it up as best you can. If I find g of f, it means I'm going to put f into g. You're always going to put the thing on the right into the thing on the left. So in this one, I'm going to put 2x squared minus 3, pull over here and put it in for x. So I have 4 parentheses 2x squared minus 3. I'll distribute the 4 and I get that. Now, if you already have the composition, you can, if I asked what's f of g of 1, well, here's f of g of x, so you could just put 1 right here and you get 29. If you didn't have that, if you didn't already have the compositions, you would do g of 1. So you would put 1 here with the 4x, you'd get 4. Then you would take that 4 and put it over here. And you get 4 squared is 16. 2 times that's 32 minus 3 is still the 29. So you can do it whether you have already formed the composition or you can do it in steps. Here's some more examples of just finding that g of f of 1 means what? You take f of 1 and you put it into g. So you could do all of those. Now, if you're finding the domain of a composition, the domain of f of g, 2 steps here. Find the domain of g, and any restrictions are excluded also from f of g. Then you find the domain of f. Set the restriction equal to g of x. So you want to find what initial value of x that are range values from g that become domain for x. So let's go through an example. So find the domain of f of g of x if this is your f of x and this is your g of x. So step 1 tells me to find the domain of g. So that means I'm looking at the denominator and I know it can't be equal to 0, so x can't be 1. So the domain of g is that. So 1 is excluded. So that's excluded in our domain of f of g. Now the domain of f, x can't be -2. So I take the restriction for f and I set it equal to g of x and I solve. So I'm going to multiply x minus 1 over here. I'm going to distribute, then I'm going to subtract 2, and I end up down here with x equals -1. So now I've got two things that are in my restriction for the domain for f of g, and it's that x can't be 1 and it can't be -1. So follow that path, follow those steps, and you should be okay. Let's go look at our problem set. All right, so if you are given h of x equals this, find h of -6. All that means is we're taking -6, put it in for each x. I've done that over here, and then you just do the calculation and you get 147. Same thing with number 2, f of 3x. So you're still just plugging in 3x where this x is. So 3x and then it's squared, so that becomes 9x squared times 6, which is 54x squared. So you're just plugging in whatever that has. State whether this is true or false. if f of x is x squared and g of x is the square root of x plus 7, then f of g of 3 is 4. So we take 3 and we put it into g. So if I put 3 in here, what do I have? So if we put 3 into g, we've got the square root of 3 plus 7. If I put that into f, then f of this thing squared is 3 plus 7. 3 plus 7 is not 4. So that is false because it is not equal to 4. Let's try number 4. There's your f of x, there's your g of x. Which of the following does f of g equals? That means we're going to put g into f. So instead of x in here, I've got 4 over x. So I have the square root of 4 over x plus 5, which is that choice right there. Let's look at number 5. These are tables, and you have x values on the top line. Then you have f of x, and you have g of x. It says, what is f of g of 1? So what you do, you go to 1 on the x line right here. And you say, okay, g of 1 is 0. So I wrote that down. G of 1 is 0. Then I go back to my x line. I go to 0, and I go to f of x. That's -1. So that's my final answer for that one. For letter B, f of g of -1. So I'm going to start -1. I'm going to go to -1 on the x. I'm going to go down to g. That's equal to 0. G of -1 is 0. Now I'm going to go back to the x line, go to 0, and I want to go to f. F is -1, so I'm there. So those seemed very similar. Let's do g of f of -1. Go to -1, go to f, you get -3. So f of -1 is -3. Now I need to find g of -3. I go to -3, g of that is 8. So you continue to do that. Now, I do want to show you, you can take a composite of something of itself. So you can do g of -2. So g of -2 is 3. G of 3 is 8. So I just wanted you to see you can do that. So we're going to do the same thing in number 6 as we were doing in this table, but we're using a graph. So you still have an x line, which is your x-axis, and you have an f of x, which is this v, and you have a g of x, which is this. So g of f of -1. So we'll go to -1 on the x-axis right here, and we'll move till we are meeting the f line. Right there, the y value is 4. So f of -1 is 4. Then I go back to the x-axis at 4, and I move till I am on the g line. The y value there is 4. So my final answer is 4. Let's do, so you would do that with all those. Let's do this one down here, f of g of 4. So if I go to 4, and I go down to the g, excuse me, I go up till I'm hitting the g, I'm on 4. So g of 4 is 4. And if I go back to 4 and go down to the f function, I am at -1. So it's just following a path. You should be able to do those. Same thing with these. You're finding g of f of 8 and g of f of 0 and f of g of 3 and f of g of 4. I've gotten them written down here. You always start out to the right, get a value, and then do it again and go to the other function. So those should be pretty good. You should be able to do those. You should also be able to do these where you're plugging into the function. You don't have a table, you don't have a graph. You've got two equations. F of x is 7x, g of x is 6x squared plus 9. So if we were doing the first one, g of 4 means we're going to put 4 into this guy. So I did that here. 6 times 4 squared plus 9, that's 105. Whatever you get here, you're going to put into F. That means 7 times 105, and that's 735. So you're going to do those the same way, just follow the path. Now let's get down to 9, and we do have to do some formulating of domains for these compositions. So it asks us a few things on each part. So first thing it wants to know, what's f of g? That means we've got to take this and put it in for x here. So I wrote that out here. You've got negative 2 over x on the top. You've also got it down here. We need to make the denominator be one fraction. So we're going to put 5x over x. Do you see that that becomes 5? That's the same thing. Then we're going to flip the denominator here and multiply. That's how you divide fractions. So I have negative 2 over x times x over negative 2 minus 5x. Those cancel out. I'm left with this. Since everything's negative, we can switch it to all positive because you can divide -1 into everything. So the final answer for A part is 2 over 2 plus 5x. The domain of that thing, remember, we need to look at the domain of G, the restriction there, and that is 0. So 0 is not in the domain of G. So that's going to be excluded in our f of G domain. And then to do the other one, we'll take 0 and set it equal to 2 plus, where did I get this? And so I took the denominator of my composite and set it equal to 0, and I got x can't be negative 2/5. So those are my two things that are excluded in the composite. We do the same thing for g of f of x. You're going to put this thing f into g. So over here, instead of x being on the bottom, now I have x over x minus 5. I will do my flip and multiply. Negative 2 over 1 times x minus 5 over x. That gives me negative 2x plus 10 over x. That's what goes in that blank. In my f function, 5 is not in the domain of f. Since that's the one that's being put into the other one, I'll do that first. Then I have to think about the composite, and the x can't be 0. So I have those two things that are restricted from the domain of the composite. So I think you can see all the work is done over here, and you can follow along on that. Let's look at number 10. Number 10 is a word problem. The surface area of a hot air balloon is given by S of R equals 4 pi r squared. R is the radius of the balloon. If the radius r is increasing with time t according to this formula, so this is r of t, that means the radius is increasing when with 5 over 6 times t squared. Find the surface area S of the balloon as a function of the time t. So let's look at what we did. To express it as a function of time, find the composite function S of R of t. So we'll substitute R of t for R in S of R. Remember, our original S of R was up here. So instead of this R, we'll substitute 5 over 6 t squared. That's a composite. When I square this, I get 25 over 36 t to the 4th. And then I have this 4 that was part of the original formula, and I can cancel that out with this 36 and leave 9. So I have 25 over 9 pi t to the 4th. So this was a composition problem. Number 11, the number N of cars produced at a certain factory in one day after T hours is given by. So we've got this right here. All right. And it says 0, T has to be between 0 and 10. if the cost C in dollars of producing N cars is this function, so let's write this. Find the cost C as a function of time of operation. So here's my N of T, here's my C of N. You're finding cost as a function of time. So that's C of N of T. So that means I'm going to put this whole thing for this N here. So I showed that in red. So 35,000 plus, and then multiply the 4,000 times that and the 4,000 times that, and you end up with this is your function, the cost as a function of time operation. So those are two application problems where we had to use the idea of composites, and that's just the start of the transcendental chapter.